Hello everyone, I am SHABNAM S.JAHAGIRDAR. Today I will be presenting my paper entitled Multifaceted Approach for Anticipating Learner Performance Using Parameter Weightage and Ensemble Algorithm Future. So in this presentation, I will be introducing my paper. Then I will be telling you about the methodology used in my paper, and then I'll be showing you the result and discussing the same, and then I'll be concluding and telling you about the future scope. So, introduction. As we know, in education settings, accurately predicting academic performance is very important for timely intervention and personalized support for the student. For this, we have developed a new prediction model which will predict the student grades. That is, we have developed a classifier model. And here, while developing the classifier model, we have selected the parameters from the data set based on feature importance score, which is calculated by random forest algorithm. And this score is applied as weights to each of the feature. And using this, we have developed the ensemble model using this parameter weightage, as well as we have introduced meta learners, which will improve the accuracy of this classifier. Compared to the earlier works on this, our work demonstrated the superior prediction accuracy as well as computational resources. So our problem definition of this paper is, that is statement is to enhance the predictive accuracy as well as the computational efficiency of student performance prediction model by using feature importance as well as ensemble modeling, which we are developing using a voting classifier. And a novelty of this is we are introducing a meta learner in this. The objective of our work is to conduct a comprehensive analysis of the impact of using this weighted parameters on student performance within an ensemble prediction model, as well as to integrate the meta learners, different meta learners with the ensemble technique to see how the prediction accuracy will differ. So these are our contribution. Initially, we have introduced the weighted parameters, which is based on the random forest feature importance score. And also we have integrated the meta learners within the ensemble technique, which we'll be seeing in the upcoming slides. So this is the summary of key publication use. So this table shows us comparison of techniques for learner performance prediction. So the first author, Ray et al., has used ensemble method with deep learning models. The research focus is for academic performance prediction, and the finding is ensemble method improves accuracy in predicting academic performance, but the limitation was the diverse data set was not used. The second author, Afsar et al., used ensemble of meta learners, and he focused on ranking and combining predictive model. A finding was ensemble technique reduced prediction variance, improving overall performance, but it lacked the label data that affects the robustness of the prediction. And the third author, Lee et al., used IFRC model with ensemble technique, who predicted the student performance in music education, and robust framework provided by ensemble technique significantly enhances prediction accuracy. This was his findings. The limitation was it was applied only on music education, so it will limit the generality. The next author, the fourth author, used a two-layer ensemble approach using stack generalization technique, predicted dropout in university classes, and the findings was two-layer ensemble model with stack generalization accurately predicts student dropout, but the limitation was it was not scalable to the larger data set. Then the fifth author used ensemble technique in using RF, that is random forest, extreme gradient boost, light gradient boost machine, and enhanced predictive accuracy of e-learning student performance. And the finding was light GM gave their better accuracy compared to other algorithms. But the study is limited to a specific e-learning platform, which may affect the generality of the result. And the sixth author um, and used Ensemble model with multimedia based big data, and the academic success prediction using multimedia data from LMS was done, and the findings were Ensemble model shows higher accuracy in predicting student success, but the limitation was it requires a large amount of multimedia data which was not available. Pick et al. Used machine models like random forest, support vector machine, and decision tree. And he identified at-risk student and tried to minimize the failure of the student. And findings was ML technique effectively reduced student failure rates by early identification with RF being the most successful. The limitation was the study might miss factors causing inaccurate prediction. Then Zhang et al. Used ensemble model combining data decision tree, random forest, and gradient boosting. He predicted student achievement in learning Portuguese language, and findings was gradient boosting with ensemble model gave the better accuracy. The study was limited to a particular scenario of learning languages. Bhagyalakshmi et al. Used a technique of multi-view deep learning with the Ensemble technique. He predicted student performance and identified high risk student, and the findings was multi-view deep learning approach increases accuracy of early identification of high student. This limitation was it was limited to educational settings and may not apply to other domains. Teo et al. Used ensemble learning technique with bagging, boosting, and stacking to predict student performance in video based learning environment. And findings was ensemble learning with boosting technique increases accuracy in video based performance prediction. The study focuses solely on video learning based learning, which may not reflect to other types of learning like blended learning. So that was the limitation. So this is the methodology of a paper, that is it shows the process flow used in a method. So initially we have collected the data from technical student, that is Government Polytechnic of Karnataka's, and this data is subjected to data pre-processing where we have taken care of missing data, and we have converted the categorical data into numerical data using label encoding and ordinal encoding, and then to have the equal representation of each classes, that is target variable grade, we have used random oversampling, and then we have applied feature importance selection based on random forest and calculated the feature importance score, and this feature importance score has been assigned as a feature weightage to each of the feature, and this has been subjected to stratified 10-fold cross validation, and we have built a base models. 6 base models we have used, which I will be seeing in the upcoming slide, and evaluated the initial prediction result. To evaluate the result, we have used 4 parameters, that is accuracy, precision, recall, and F1 score. And then we have combined these base model using hybrid ensemble model using a voting technique. Apart from this, we have done hyperparameter tuning so that we get the better accuracy, and we have also subjected it into a meta learner to further improve the performance. Again, performance is evaluated by the 4 evaluation parameter, that is accuracy, F1 square, precision, and as well as recall. So this is the data set used. We had 23 parameter and our records of 1,002 students, and we had a multi-source data set. That is, we had the background data of the student, like SLC, medium of the study, their residing region, their family, yearly income, etc. We had their also data about their digital interaction with the with the online learning system, like how many times they log in, duration of online learning lectures, time spent on online assignments, etc. And as well as we had their physical activity data, and even their library visit. So totally we had the 23 parameters about them as in this table. So for data pre-processing, we have first initially found out the data inconsistency and missing values. And in this, 8 records with significant missing values were removed, and 4 records were corrected using mean imputation for partial missing data. So next we have converted the categorical data into numerical data using 2 approaches. That is, one is ordinal encoding, second is label encoding. In ordinal encoding, we have applied to the variables which has inherent order. So for example, family, yearly income, then we have used access to internet and perceived ease of online learning. And label encoding we have used for nominal variable without inherent order. For example, we have used it for attributes like SLC, medium of the study, residing region type, basic computer skills, types, etc. Then we have handle class imbalance using random oversampling for the target variable, which is grade in our case. This is to have the equal instant of all the classes. And after doing this, we have 398 instance for the each of the target variable. Then we have calculated the parameter weightage calculation using random forest algorithm. This is used to calculate and assign the weightage to our 23 features which we had seen in the previous slide. And the target variable we have in our study is grade. So this is how we have calculated the feature importance using the impurity, this factor, and this is the formula used to calculate the same for each of the feature. So this is the feature importance scores we have after applying the previous formula, and that is we have got. And for the 23 parameter, these are the scores. That is, for weekly login frequency, we have got 7.27 as the score. Time spent on online assignment stands second in the with the feature importance score of 6.68, and duration of online lecture viewing stands for third, that is with 6.09, so on, wherein basic computer skills has the least feature importance score of 0.76. So next we have assigned the weights to each of the features. So this is done by calculating the weights, which is calculated by for xw is equal to w1 into x1, w2 into x2, so on for last wp into sp, where p represent number of parameters. So basically, for with each feature we have multiplied its feature importance score to get a weighted feature set. So this is how we have built our hybrid ensemble model. So this is there wherein we have sent this weighted feature which we calculated in the previous slide we have subjected to stratified k-fold cross validation, and we have used 6 base learners, that is random forest, support vector model, decision tree, k nearest neighbor, gradient boost, extreme gradient boost. So these 6 classifiers we have used, and we have combined it using a voting technique, and again it is subjected to a meta learner in each time. While executing each time, we have used again one of these base learners. That is, first time we have used random forest, then SVM, decision. So meta learner is again learning from the ensemble, and then we get the final hybrid ensemble model. So while tuning the performance, these were the hyperparameter configuration we have used. This we have arrived using the method of grid search, And for the random forest, this is the hyperparameter configuration. We have got the best to this. So on we have for other base learners as well as meta learner. So for the performance evaluation, as I told in the previous slide, we have used four this metric, that is accuracy, which evaluates the model overall correctness. The formulas for the same is there in this column. And precision is assessment of how many are really positive. Recall, assess the how many are predicted positive, and F1 is a harmonic mean balance between precision and recall for a comprehensive measure. So we have this next is implementation, which we have implemented using Google Colab, and we have used a Python language for writing the code. We have used the different machine learning libraries like scikit-learn, that is for data processing and model training. TensorFlow we have used for advanced machine learning tasks, and XGBoost we have used for gradient boosting and model optimization. So this is the result. This table shows us the performance comparison when we have used weighted ensemble, weighted features as well as non-weighted features. So this is the accuracy, precision, recall, and FN score when I not applied any weightings feature importance score, that is 86.68% accuracy I have got, whereas when I have used weighted features I have got 92.91. So we have got an improvement of 7.2%. So as we can see, similarly in precision, recall, and FN square, we have got a improvement of 6.9%, 7.0%, and 6.8%. So by this experiment we conclude that the introduction of parameter weightage significantly enhanced the model ability to identify at-risk student and improved overall performance metric. So this result shows I've taken actually have done the experiment for top 5 feature, 10 feature, in the 23, top 15, 20, and all 23 feature. I have run the experiment. In that I have, as we can see in this top 5 features. So when I consider top 5 ranked feature, I have run it against the only ensemble, and then I have subjected it into meta learner. So when I subject further it to meta learner, I get the better accuracy. So for the top 5, when I used meta RF and meta KNN, I got 92.73% accuracy. Same thing for top 10 feature also. A normal ensemble gave little lesser, far lesser accuracy compared to when I subjected it further with a meta learner. So I can conclude here is hybrid meta learner model outperformed basic ensemble across all feature sets. So this is the comparison of full feature set. When I took all feature set also, maximum I got the accuracy of 98.38, and whereas with the normal ensemble it was 86.68, and also you can see whereas for the top 10 it was 97.13. So top 10 as well as top 3 accuracy was comparable, but the execution time for 23 features were 37.675 seconds, whereas 10 features were 29.35 seconds. So what I concluded by this is, though with the top 10 as well as top 23 gives nearly nearly same accuracy, but computation time increases with the number of features. So in that case, we have to use the weightage and use the less number of features, and with this you will get better accuracy, and also saves the computation time and resources. So to conclude, prediction accuracy can be improved by assigning weightage to the features, and also computational efficiency will be good with the smaller feature set, and compared to hybrid ensemble, a general basic hybrid ensemble, we get a far more better accuracy if we introduce a meta learner to its output. So weighted hybrid ensemble gave us a better, higher accuracy. So to conclude, we introduced a novel hybrid model using Ensemble with MetaLearner in this paper, and we have achieved accuracy between 96.19% to 98.22% by integrating parameter weightage and Ensemble fusion. So the model facilitates early prediction, enabling educator to implement targeted intervention for at-risk student. So future scope, we can implement advanced machine learning and deep learning technique for the improving the accuracy of the model. We can also take some external parameter, 23 attributes I have taken. We can take some more attributes that will give a holistic view of a student. And then third one is we have to continuously refine and evaluate the hybrid model to align with the evolving education context. So these were the references used for my presentation. Thank you. Thank you for listening to me. So for any further query, you can mail me to my email ID, that is shabnam.jagirdar@gmail.com. Thank you. Have